stuff. So let me give you a case, maybe if you have an old school calculator, that sort of thing. So remember, 4.4 is not on tomorrow's quiz, but obviously it will be on our chapter test when we get to it. Okay, this is some good review stuff from some of our previous logarithm knowledge. Remember, an ln is a log base e, so they cancel each other out. I can do those all day. Same thing here, your log base 5 and your 5 to a power cancel each other out. No reason to get these wrong. And of course, the last one, give it to me, what's the last answer? 9x, all right, cancel each other out. Because of course we know that logarithms and exponentials are inverses of each other. Square root, squaring, cancel each other out. Logs, exponents, cancel each other out. I can't help but give this feel. All right, there are 3 laws of logarithms that we're going to start using. Now you might be like, what is the point of these? Okay, that's a good question. It's kind of leading you up to kind of one of our ultimate goals of this chapter is you want to be able to solve some equations that have logarithms in them. So these properties are where they're going to be helpful when we start solving. We're going to start condensing, maybe making some expressions simpler, etc. So that's where it's going to come into play when we start solving equations. All right, product property. Now, for dramatic emphasis, I know you know there's a times between U and B. I'm just going to put the dot there so you know product, of course. So if you have a log of a product, that is the same thing or equivalent to if you do the log, notice it's base A, that's why I put the A on, and you do the sum of each of those. So product expands out to addition. So I'm going to fill in addition here on the blank. Now, once you know that one, you really know the quotient property. Because if product goes to addition, quotient, we're going to use fraction bar, quotient is going to expand to, what do you think? What's your guess? Subtraction, Owen for the win. Avery would be so proud. So log base A of the numerator, which is U on this case, minus log base A of the denominator. Now, power property, the last one. That's a very sloppy subtraction, that's an N there. Your power property, or exponent. Another equivalent form of this, if you have an exponent, in this case it's that little tiny n, it is the same thing if you put it in the front and make it n times the log. Now, do I care if you have the dot for the times? No, I'm just, drama. So power property expands to multiplication, I'm just going to abbreviate multiplication there, by the exponent, or the power, whatever you want to say. So these are the 3 properties we're going to start using, practicing today. Again, they're important when we start solving equations. So product expands to addition, quotient to subtraction, and a power can be dropped in the front to multiplication. And we're going to go the opposite way, meaning maybe we're going to have 2 logs subtracted. I'm going to condense it to 1 log divided, or 2 logs added. I'm going to condense to 1 log multiplied. And just to prove to you that this really is true, this isn't on your notes, but I just always throw some stuff in here. So if in your calculator, because I've already showed you where that math log-based function is, I just made up something, 35. I punched it in. I'm like, well, 35, of course, 5 times 7. I expanded it out to addition, and you can see you get the same thing. It's just an equivalent way to write it. 2/4, 1/2, all the same thing, just a different way to do it. Same thing here. If you have a power and you drop it in the front, you get the same thing. So just proving to you that those actually do really are proper. I just didn't do quotient because I don't know, I just didn't throw it up here for you. Okay, use properties of logarithms to rewrite and simplify. Now, I know, you know, there's that log function in your math menu of your calculator. You cannot use that right now, because I hear some of us trying to type it in, which would be easier because it asks you to use the properties and to simplify. Okay. So we have to kind of go around it the difficult way, so to speak. So the first thing I'm thinking about is this 243 obviously is kind of large. And you kind of do need maybe your calculator for this. I'm trying to figure out, does 9, because you're in a base 9, does 9 go into 243? That's what I'm working on right now. Well, I just kind of have a little bit of a good number sense. Shocking, I know. I'm just like, well, I know 243 is 81 times 3. I just know that. I don't know why. I just happen to know that. Of course, you can punch that in your calculator. So right away, I'm like, oh, 81. That's 9 squared. 3 is 3 for right now. I'm just going to roll with it. Now again, I'm trying to use 9 because that's our base. I know the 3 is not in a base 9 yet, but I'm going to get it to that. What I'm going to do now is you have your product, which I'm going to expand out to addition. So I have log base 9 of 9 squared. That's super easy. You should know what that's going to turn into. And then log base 9 of 3. Now, like I said, this is super easy. This just simplifies down to 2. I got to do a little bit of work on this guy because I don't have the 3 using the 9. I want base 9. So I'm like, oh gosh, here we go. This is going to be a fraction exponent. We saw something similar yesterday. I know 3, of course, is the same as the square root of 9. But I want it 9 to a power. I don't want it in a root style. So square root of 9, of course, is 9 to the 1/2. So much little nitpicky number sense. And then, of course, your base, cancel out, you have a half. 2 plus a half. So we just did a truckload of work to get 2 1/2, which couldn't we type this in our calculator in like 1 second? Maybe 2 seconds if you type slow like I do, okay? So kind of irritating, I'm not gonna lie, but we're kind of leading you up to prepping you for things like this, where you have the variables and you literally cannot type it into your calculator even if you wanted to. So that's what we're kind of working our way up to. Okay. Obviously that I would just do it in my calculator if I was on a test or something. I'm going to try to rewrite 9 using 3. Now, we all know 9 is 3 squared, right? That's pretty simple. We got it. But I'm going to make it 3 squared, and I kind of wrote over it. You have the other squared. So it's going to be 3 to the 4th. And 9 squared is 81. 3 to the 4th is 81. 2 to the 4th, I'm just rolling with for right now. Now I'm going to use my properties. Again, we could type this in our calculator in 2 seconds. I'm well aware of that. Practicing our properties. Product expands to addition. So I've got this part's nice and easy. Log base 3, 3 to the 4th. I know you know what that's going to turn out to be. And then I've got my log base 2, or log base 3, sorry, log base 3 of 2 to the 4th. This is easy. This, I'm like, okay, what am I going to do with this? 2 to the 4th. What's 2 to the 4th, really? 2 times 2 times 2 times 2. Who's got it? 16. How are we going to write 16 as 3 to some power? Can we? I mean, 3 squared is 9. 3 times 27. Even if you think about doing like a fraction exponent, it's not going to happen. We can't do it. I'm not going to panic. We're just using our properties. The only thing I really could do, and I don't know if it really makes it any simpler per se, but I'm just going to do it, is I'm going to use this power property where we just drop the exponent down in front of the log. So I'm going to, because I can't do much with this because I'm not supposed to be using my calculator, so I'm just using properties. I drop the 4 down there. I'm not putting the times symbol in because I can't make 16 in terms of 3. I just can't do it. It's not going to happen. Now, again, we could have typed that original problem, bless you, in our calculator and had an answer in like 2 seconds flat, but they want us to use properties, practice our properties. That's as far as I can take it for right now without a calculator, unfortunately. All right, we've done some product to addition, obviously. Let's live on the edge and do some quotient. Now remember, quotient expands out to subtraction. Numerator first, denominator second. So I'm going to make this the ln of e to the 5th minus the ln of 7. That's a very sloppy 7. I just sneak it in there. Now the first one's nice and easy. What's ln of e to the 5th become? 5. I can't use my calculator. We're just using our properties. I don't know what ln of 7 is off the top of my head. As far as I can take it. So just kind of warming you up to use some of these properties on the problems that have variables, and there's no way I could punch it in my calculator, such as the next round of problems. Okay, we should always read the directions, right? Use properties of logs to expand. Now here's the key, what operations you can have in your answers. You can have sum, addition. You can have difference, subtraction. And then constant multiple of logarithms. That is like this last one where you drop the power, here it is, where you drop the 4 down in front. Constant multiple, 4 times the log. That's what that means, 4 times. That's the only operations you can have in these, too far. So, I'm going to make this pretty easy. Now, I have product, so I can't have product in my answer, only some difference, and I can times the log by something. I'm going to expand product out to addition, of course. Notice, I didn't put the tens on, did it on purpose. Do you need the tens on? No, remember that's your common log. If you do not have the base of a 10 written on there, it's implied to be in 10. It's hot in here today, we're tired. I just didn't do it to review that. Okay, that's it, far as you gotta go. I love it. Quotient expands to subtraction. So log of the numerator minus log of the denominator. And again, since it's base 10, I just didn't put the tens on. You can put the tens on, doesn't matter. Common log, don't have to have the tens on. Too easy, love this stuff. Okay, again, directions, can't have that exponent. I can't have a power. So I'm gonna use my power property where I just drop that down in the front. So I'm gonna make it -3 log base 6 of x. And that is in the directions when it talks about a constant multiple of a logarithm. You're multiplying the log by -3. -3 is a constant. Got it. Okay, nothing in the directions says you can have any roots whatsoever. So the first thing I'm going to do, we've seen these darn roots popping up all the time in these fraction exponents. Let's see what the first, I'm going to rewrite that as z to the 1/3 power. And some of you might skip that step, like you just know it's to the 1/3 power. Now again, directions can't have a power, so I'm just going to drop that in the front and make it a constant multiple. So some of you might just go right to the answer, and then that's totally fine. So any questions on the first 4? Pretty basic, pretty basic. You know, jazzing it up a little. Ooh boy, we got 3 variables in it. Now you have a couple operations here. You have product, of course, between the x and the y, and then you've got division, the quotient. My advice, I would do the quotient part first. So I'm going to expand quotient out into subtraction. So I'm going to do the ln of the numerator, I'll deal with that in a minute, minus ln of the denominator. Now of course I can still keep going because you have product between x and y. So I'm going to expand that out to my addition. So I'm going to make this ln of x, ln of y. And of course I still have my minus ln of z. And one kind of quick, easy, like mental check, so to speak. Sometimes I get asked a lot of times, like, how do you know how many like ln's you should have in your final answer, or logs in your final answer? Well, you have 3 different variables in the problem, x, y, and z. So I should have 3 logs in the problem when I'm all said and done. So right away over here, I'm like, I've got 2 variables, x and y. I better have 2 logs in my answer when we're done. Now, again, I don't like the root. We can't have a root. So right away, I'm like, ooh, that's a 1/3 power. So I'm just going to rewrite it 1/3. Or do anything. Some of you might skip that. Now, you've got some choices here. You could apply the 1/3 to x and y. It really doesn't do anything for me. Or I'm just going to move it right away and use that power property and drop it down in the front. Now the question is, am I still going? Well, you have 2 different variables, x and y. Do you have 2 logs in this?
Yep.
Do we have 2 logs? I only see one, I see one, I see one. So I'm still going, I'm still going. So quotient has to expand out to what? What operation? Subtraction, yeah. So I'm going to make this the ln of x minus ln of y. I know I haven't written the third, I'm still writing the third, I'm getting to the third. The third, of course, applies to this entire expression. So notice I got fancy and used parentheses. You're welcome to leave it like that, or if you want to distribute it through, you'll get the same thing. And like I said, you have choices on this. You could have put the third on the x and the y, and then expanded it out and did the power property. You'll get the same thing. It doesn't matter to me how you do it. You'll get the same final answer. So any questions on F? Starting to get a little more tricky. All right, so answer this question. How many different variables are in this thing? Easy question, easy question. How many variables? 3. So you better have 3 ln's in your final answer. Okay. Now, again, my pro tip, we get a lot of operations here. Let's start with the quotient. I'm going to expand that out to subtraction. I don't like that square root of x either. I'm just right now going to make it to the half. Saves you a little writing. So I have 2 ln's. We said we need 3, so I know I'm still going. Okay. Well, product. Product, I'm going to expand out to addition. So I'm going to make that ln x to the half, ln y to the 4th, and I still have my minus ln z to the 4th. Last thing. Almost done. Last thing, of course, according to our directions, you can't have those exponents, so I'm just going to drop those down. So I'm going to make it 1/2 ln x, 4 ln y. And I know some of you might combine some of these steps that, you know, I'm just for your notes doing it step by step for you. And 4 ln z. Got it. On the home stretch on these. Condensing I actually like better. That's the next round. You're going backwards. Okay, same thing. We got log. We got a couple expressions, the numerator, denominator. So first thing I'm going to do is deal with the quotient, and I'm going to break that out into subtraction. Now ln of x is pretty simple. ln of x, that's going to stay. I don't like the square root, of course. So I'm going to think out that as a 1/2 power. I wish it was x squared minus 1, so it factored, but no such luck. Now, I really can't do a whole lot from this point. The only last thing I really could do is drop this 1/2 in the front of there. Like I said, I wish that was a minus. I'd factor it out, then I could use my product property. But I can't do anything else with it. It is a plus. Looks kind of weird. It just is what it is. Elliot.
Can't you distribute the 1/2 into the expression?
No, because you have addition. You could if that was product in there. If that was x to the half times 1, then you could raise everything to the 1/2 power. You could use your exponent property. Okay, so expanding, I'm going to be honest, it's really not my favorite, okay, just because clearly it takes more room and more work. And I don't think it's as useful as condensing. I like condensing because you will see that come up in some of the equations we're going to solve, which is one of our ultimate goals of this chapter. Plus, it just seems, I don't know, it just makes more sense in my brain to try to simplify things down to something smaller. So now you're working backwards, meaning, I'm like, oh, okay, I got it. So condense the expression to the log of a single quantity. That means 1 log in your final answer. That is it. Uno. Okay, 2 ln's added, condensed to 1 ln multiplied. I mean, do you need the dot for the times? No, but you know, I like my drama. Done. Same thing. 2 logs subtracted, condensed to 1 log divided. And I'm going to use the fraction bar for my division, so I'm going to make it 8/t. Done. Single log. In our answers, we got it. So like I said, I almost like, like the condensing a little bit better because you'll see that more so when we start solving equations. Now, I'm looking at C and I'm like, it looks pretty small to me already. There's one log in it, but we want it log of whatever. I don't want that 5/2 in the front, so I'm going to go ahead and tack that on as the exponent. Or I suppose, if you wanted to get fancy, because we're all about fancy in here, this would be the same thing. If you're feeling fancy, square root, that's the 2 there, and then the power. I don't care, either one. You don't have to be fancy about it. Okay, same thing. I see there's 2 logs in it. I want to shrink it or condense it down to a single log. So a couple things I see. One, you've got the 2. I mean, that doesn't really freak me out. That's just the power. That's going to be easy enough. So I'm going to tack that on. That deals with that. And then last thing I'm going to do, I have 2 logs added. I'm going to condense that down to 1 log multiplied. Now, I don't care if you leave it like that. You can distribute the x squared through if we're feeling fancy. The only thing I'm going to say if you distribute it, I'm going to throw some parentheses around it because I want to make sure we're implying that you're doing the natural log of that entire expression. Okay? We're here product, of course, we're doing it all. And it doesn't matter to me, I really don't care if you distribute or you leave it. It makes no difference whatsoever. It might matter when we start solving the equations and you want to have that distributed out. But for now, I'm just getting used to our properties. All right, couple things I see. Subtraction and the 2. Well, the 2 is easy enough. We know that's the exponent, so I'm going to deal with that at the end. Now let's do the subtraction. That condenses to division. And I'm just going to use my fraction bar for division. So my numerator is going to be x. Denominator is going to be x plus 2 squared. Because remember, we attach that 2 as the exponent. Again, I don't care if you FOIL out the bottom or leave it, it doesn't matter. I'm just going to leave it. Got it. All right, getting crazy now. Got more stuff for you. And I really love using S. Looks like a 5 when I write it in my handwriting. Okay, 3 LNs that we need to condense. If you're like, oh gosh, I don't even know where to start. Always, order of operations. We work left to right. So I'm going to start with these 2. I'll deal with the end when I get to it. Now, easy thing, of course, that 3 is just a power. So I'm thinking, okay, I've got ln of s cubed, and then the half's the power 2. ln t to the half. And some of you might skip that and go right to, hey, I've got addition, I'm going to make it product. I just didn't put the time sign in there, you know it's product. I haven't forgotten. I still have my minus 4, ln, still have it. So I'm just working left to right. Combine the first 2 together, and then go to the third one. Now, a couple things. We've got the 4, that's easy. I know that's going to be the exponent. We'll just throw it on there at the end. And of course, subtraction is going to go to division. So my numerator is going to be the s cubed, t to the 1/2. Denominator, don't forget to put the 4th power on it, t squared plus 1 to the 4th. Looks a little crazy, but I don't really want to write this out 4 times and FOIL it all the way out. Nothing's going to cancel with it, so I'm just going to leave it, and that is what it is. I've got it down to a single log, which is all it asked me to do. Come on. Any questions on that? All right, I love this stuff. Home stretch. Oh boy. Okay, a lot of stuff here. A lot of stuff. Now again, I'm not going to panic. We're going to think order of operations. First thing that's drawing my eye are those brackets, the grouping symbols. PEMDAs, parentheses, grouping symbols, or what is it, gems now? Some of you know. So I'm going to start with this. I'm leaving the 4, I'll get to the 4. I'm working on inside the brackets. Well, product, of course, I'm going to condense to multiplication, addition to product. I don't care if you distribute or not. I might. We'll see what we have. Now, I haven't touched the back. I'm just filling in, because I'm dropping stuff. I'm just filling in the minus 2 ln z minus 5. Okay. So I'm still kind of working in the brackets. And now I'm kind of like, oh, what do I want to do with this? I know the 4th is the power. It's going to go, of course, on both of these. So I'm thinking to myself, well, I might make it z squared. I'm thinking about it being z squared 5z. And then I'm just going to throw that in parentheses and put the 4th on it. Let's just make our lives easy. That's probably the smallest, easiest way to write that. I'm going to throw the 2 on the power back here too. So I'm going to make this ln z minus 5 squared. All right, home stretch. We're going to condense this down from subtraction to division. So of course I'm going to have my z squared plus 5z to the 4th. Super glad I don't have to FOIL that out. And then z minus 5 squared. Looks looks a little crazy. But all we have to do today is condense it down to a single logarithm, which we did. Okay, easy enough. That's as wild as it gets. Homework kind of goes the same way, kind of some easy basic ones, and then you can obviously see the last couple get a little crazy, but not so awful. All right, last thing, just for fun, you know, food for thought here. So we're looking at all these laws of logic, of course, just because sometimes people like to get carried away here. If you have addition, you can't just distribute the log through there. It is not an equivalent number. Just like when I showed you that log when I had the 35 and I made it 7 and 5, doesn't work on addition. Same thing here. Like I have kids that want to always do weird stuff and make it like log of 3. Not going to be the same thing. So don't get crazy. Stick to the 3 logs. Don't make your own. That's my spiel on that. Okay, now, I like this. This is the law of forgetting, actually, is kind of what it is here. It's kind of a funny problem. If a task is learned at a performance level, P within a time interval, T, the performance level P satisfies where C, boy this is wordy, is a constant that depends on the type of task, and T is measured in months. So first thing that jumps out to me, I'm like, okay, T is in months. I'm going to keep an eye on that. Okay, solve for P. Okay, all right. So it wants me to get this P by itself. Interesting. So one thing, I'm like the right side looks a little messy to me, a little messy. So I see subtraction there. I'm going to condense that down. So subtraction, just like we were doing, condenses to quotient. So on the top you have that P sub 0, and then the bottom's going to be the T plus 1. And I'm like, oh man, piece of cake. From our earlier lessons in properties of logs, if you have the same thing on either side of an equation, cancel. Now it looks a little crazy, but did we achieve the goal? Do we have P solved for? Do I have P alone? Yeah, looks weird, but yeah, okay. A lot of variables in it. Now, score on a history test is 90. So that's your initial score, your starting score. So that's the P sub 0. So I'm just thinking about that as I keep reading this. What score would you expect to get on a similar test after 2 months? Okay, I'm on it. And then we'll do a year. I'll do the year in a minute. So I'm just going to plug these numbers in and see what we come up with. So my initial score, 90. And then of course, oh man, I lost the C. Hang on, I got to get the C back. My blue marker here kind of wrote over it and I lost it. I lost the C here. C is your exponent. Let's make this T plus 1 to the C power. My big smartboard marker wrote over it and I missed it there. My bad. My apologies. Okay, and it tells you C is 0.2, so I don't really have to do anything with that, 0.2. Now, we're doing, of course, that's going to be our formula. I'm not going to rewrite it. We can just put the number in. First, we're going to put a 2 in here for the time. I'm going to pull up my calculator, punch it in. Then, be careful. Then they want you to do it after a year. Remember, T is in months. Easy question, how many months in a year? 12. So then we're going to calculate it with a 12. We don't have to rewrite the formula both times. We just need to get our calculators out and be conscientious of punching this in. Let me slide it over here a little bit so it doesn't cover up the whole thing. Okay. I don't need it full screen. I just need it moved over. There we go. Okay. I'm just typing it in 90 divided by, I'm going to put it in parentheses. I'm going to do the 2 first. So 2 plus 1. Well, yeah, I don't really need I can do 2 plus 1 in my head. 3, and then the 0.2. So, well, 90, the original score is a whole number. I'm going to round this to a whole number. So, 72. Not great. Not awful. Then I'm going to put the 12 in. Let's see after a year how we do. This one scares me. So if I put 12 in there, a little mental math, 12 plus 1, 13. And then 0.2 still for the exponent. Oh man, that's really super depressing. So, the law of forgetting. You originally get a 90 on the test. If you take it 2 months later, you'd be down to a 72. That's how much you would forget. If you take it a year later, you're down to a 54. That's how much you would forget. That's kind of depressing if you ask me, but True. Very true, probably. I don't know. Maybe. Elliot.
Why is the 54 rounded down?
Wasn't it 53?
Oh wait, I typed it into my calculator wrong.
Okay, no worries. No, I was like, maybe I miswrote it, Elliot. You never know here in this heat. Okay, last thing I have for you. This, like I said, I think is kind of obsolete maybe because of the calculators you have, but every once in a blue moon, I have somebody that does not have that math menu log base in their calculator. Even if I just had like a cheap $9 scientific calculator, I can do the log at any base you want. Okay, bless you. So, it's called the change of base formula. I'm going to type one in just to show you, just to make sure everybody can type these in, but let's take a look at it. So if you have, they're just using b for the base and obviously x, you could just hit your log key on your calculator of x divided by the log of whatever the base is. You could even also do a ln style. Do the ln of x over the ln of the base. Now, like I said, most of you, this is obsolete. I've already showed you this. You know you have that math menu log base. But just to prove to you, just to prove to you, type that in however you want with your math menu log base. I could do the log of 7 divided by the log of 3. You're going to get the same thing if I do my math menu, my letter A, and then I type it in that style. 1.77, pretty exciting. So it doesn't matter, just different ways to type it in. Make sure you know how to use your calculator. What do we round it to? 3, so 1.771. You could also, too, just to prove it, you could do ln of 7 divided by ln of 3. And you get the same thing, okay? Most of you, I'm guessing, and I don't care how you type them in, like on a test or quiz, it will just say evaluate the following, round to however many decimal places. I'm going to use my math menu on it, because why not? Okay, 1/2, you can do 1 divided by 2. I'm just going to do 0.5, seems a little easier to type in. That one comes out nice. So just make sure you know how to type those in your calculator. I do not care how you do it, as long as you know how to use your calculator. Okay, final thing, and I kind of showed you this yesterday, and this is a good review one for our quiz tomorrow. Use the change of base formula. Yeah, I'm not. And a graphing calculator gotcha. I don't need the change of base formula. We have our graphing calculators with our log base. Let's just type it in. So my y equals my math menu, my log base. I'm just typing away here. 2x minus 1. I was going to say I'm going to try not to go in a spiel about how I hate Texas Instruments, but that graph makes me want to. If you just draw that, am I going to be happy? We have to know, I don't know why, these calculators do not show you the whole picture. You have to continue the curve. So I'm going to pull up the T-chart here because that irritates me. Let's get some numbers. So I'm going to use 203152. 203152. Now, before I draw it, and plus this is a good review for tomorrow's quiz, we should, from the equation, be able to give our domain. I know it doesn't ask, but I'm going to do it. Our vertical asymptote. Super important stuff when we do log graphs. We've said it a million times. You cannot do the log of a negative. You have to make sure that that x minus 1 is over 0. Which is also now your vertical asymptote. I always like to put the vertical asymptote because, well, A, you know my drawing skills, and I want to know like how far over to draw this curve. So now that I've got that on, I feel confident drawing the curve. Got it. Let's see. Well, for your quiz too, what if I asked you what is the x-intercept? 2, 0, right? That's as exciting as that gets. What if, I'm going to rewrite this y equals style. What if, thinking about your quiz, I asked you to put this into exponential form? 2 to the y equals, and then of course, I mean, you can use your calculator tomorrow, obviously, but you know I love a no-calc quiz maybe next week. If I couldn't use my calculator, I would add the 1 over and make it x equals, and then I could do my T-chart and continue on from that. You get to use your calculator tomorrow. Just always thinking ahead. I'm always thinking ahead, kids, right? Any other questions on that graph? Always thinking ahead. That's how we roll here. Okay, so I am going to give you this